In this session, we are going to work through question 11 from this booklet. So let's go to question 11. This topic is on vectors and matrices. So we have a 2x2 matrix A and B, and you are asked to find the product AB, or to find AB. So let's work that out. So we have the matrix A as 1, 2, 2, 5. So we have 1, 2, 2, 5. And that's matrix A. And then matrix B now is 5, minus 2, minus 2, 1. So A times B there would be AB. So we're going to have row times the column. So we're going to have 1 times 5, that's 5, plus 2 times minus 2, that's minus 4. So 5 plus minus 4, that's just 1. And 2 times 5, that's 10. And then 5 times minus 2, that's minus 10. So 10 plus minus 10, that's 0. Okay? And then 1 times minus 2, that's minus 2, plus 2 times 1, that's 2. So minus 2 plus 2, that's 0. And then we have 2 times minus 2, that's minus 4, plus 5 times 1, that's 5. So minus 4 plus 5, that's just 1. So what we get for AB is 1, 0, 0, 1. And this is called the identity matrix. And the identity matrix behaves just like the number 1. So 1 times a number will just give you the number. So let's now look at part 2. You're asked to determine B inverse. So the inverse of the matrix is 1 over the determinant. So let's do the determinant first. So there's a process in finding the inverse of the 2x2 matrix. So let's find the determinant first. So we have the determinant of B. So the determinant would be the product of the elements in the leading diagonal. So 5 times 1, that's 5, minus the product of the elements in the non-leading diagonal. So the non-leading diagonal here is this one. So minus 2 times minus 2, that's positive 4. So the determinant is just 1. Now the inverse, B inverse, is 1 over the determinant. So it's 1 over 1, which is just 1. And then we interchange the elements in the leading diagonal. So we interchange 1 with 5. So we would have 1 there and then 5 here. Then the non-leading diagonal, we multiply it by minus 1. So minus 1 times 2 would just give us 2. And that would be 2. So B inverse really is 1, 2, 2, 5. Let us look at the matrix A. B inverse and A is the same. Okay, so we have found that out. Okay, so now it says given that we have the matrix B times xy is equal to 2, 3. So we want to write xy as a product of the two matrices. So, okay, so we have the matrix B. We note that the inverse of B was just this. So we're going to have the matrix B times its inverse, and when we times it, this is what we get. And this behaves like 1. So 1 times xy there would just give us xy. So we're going to write it out fully. So we're going to have the matrix B, which is this. So it's going to be 5 minus 2 minus 2, 1. So that's the matrix times its inverse, which is this. 1, 2, 2, 5 times xy so that would equal to the inverse, which is 1, 2, 2, 5 times the right hand side, which is 2, 3. So nothing really changes with the matrix here. If you notice, the only thing that we put in is the inverse. We times it, both sides. So we would still have 5 minus 2 minus 2, 1 times xy equals to 2, 3. So the only thing that we put in is the inverse there. We multiply. So matrix times the inverse gives us the identity matrix, which was 1, 0, 0, 1 times by xy equals to the right hand side. So we can evaluate the right hand side there. So we would have 1 times 2, that's 2, plus 2 times 3, that's 6. So 6 plus 2 is 8. And then we have 2 times 2, that's 4. And 3 times 15, 5 times 3, that's 15. Let's do it again. So we have 2 times 2, that's 4. Plus 5 times 3, that's 15. So 15 and 4 is 19. We know that the identity matrix there behaves like the number 1. So 1 times xy would equal to 8 and then 19, which means that we have x equals to 8 and y equals to 19, and that's the answer. Okay, let's just move on to part B of the question. So the diagram below, not drawn to scale, shows triangle JKL, and you're given that JM is 1/3 JK. So JK is this. So JM is 1/3 JK. So if this is 1/3, that must be 2/3. So that would be 1 to 2. That's the ratio, 1 to 2. Okay? Remember that. Now the next bit is JN is 1/3 of JL. So JN is 1/3 of JL. Okay, so that's JN. Okay. So if this is 1/3, it means that this would be 1 part and that would be 2 parts. It's 1 to 2 as well. 2 part. Okay. Now it says copy the diagram in the booklet, so I've annotated the diagram. Okay, so that's fine. Now it says given that JM is U, so we can annotate the diagram. So JM is given as U. So I'll use a different color for that. JM is U and JN is V. That's V. Okay. So we want to write an expression in terms of U and V for JK. So let's look and see JK. JK, it would be the full length. So if this is U and if this is 1 part and that's 2, it means that this would be 2U. From M to K would be 2U. MK would be 2U. Okay, so it means that if this is 2U and that's U, if this is U and that's 2U, it means that the full length JK would be 3U. So we can write down JK as 3U. Okay, now let's move on to the next part of the question. We want to find MN. MN here is the resultant, mn, let's put the resultant on it. So mn. Okay, so to get to mn, we can travel mj, which will be minus u, and then jn, which is v. So we can write that down. Mn would be minus u plus v. And then KL. KL, we put the resultant on here. So to get to KL, we need to travel KJ. We know that JK is 3u. We know that this is 3u. The full length is 3u. Therefore, this we would have to go minus 3u. So that would be minus 3u plus JL. The full length there would be 3v, because if this is 2, if that's 2v here, MNL, it means that the full length there would be 3v. Okay, so it means that KL would be minus 3u plus 3v. So part 3 now, you are required to deduce two geometrical relationship between KL and MN. So let's look at KL and MN. KL and MN. So MN is minus u plus v and KL is minus 3u plus 3v. So from this we can see that MN is parallel to KL. So that's the first geometrical relationship we have spotted. So MN is parallel to KL. Let's write that down. So the first one is MN is parallel to KL. And the next geometrical relationship that we have spotted as well is, if we factor out 3 here, we're going to have 3 into minus u plus v, which means that KL is 3 times the length of MN. So KL is 3 times MN. So that's the second geometrical relationship we have found there. So here ends question 11.